Hey everyone, what is going on? I'm the Savage Coder. Welcome to episode 7. Today we're going to be talking about classes. Classes are really important. No, not glasses. Classes. You know? When we talk about classes, we're talking about more complex data types than just a number or a string or a Boolean. It's something that represents a real-world object, and that's classes. Oh, not glasses. It's out of here. Let's get started. So let's talk about classes. Why? So why do we need classes? Classes are a concept that is similar to a template or a blueprint. A class can represent more complex things than just a simple string or a number or a Boolean. Let's say we were creating a business software where there were customers and invoices. We could create a class that represents the customer. It could have the customer's name, first name, last name, their address, their contact info. It might hold a list of invoices of things they've purchased in the past. So we can work with that one class, create instances of those classes, and an instance would be customer 1, customer 2, customer 3. They're all still customers, but they all are the same class. Let's take a look at this in more detail. In this example, we're going to talk about someone who's logging into a website. So we might want an object that represents that person logging in. All we're really interested in is their login and their password. So we could make a simple user login class called user. What's unique about class user? Well, it has two public properties, a login and a password. The data type for each of those is string. We'll talk about what properties are in a little bit, but for now, let's assume that they are a way to access the login and the password inside a user class. So how would that wire up in the real world? Well, our class is user, and it has two properties, a login and a password. So you can imagine that if we could kind of connect the login property of our user class to the login text box on the screen and the password to the password text box on the screen, as a user types in their login and password, we're actually populating those two strings in the user. Once the user clicks the login button, there would be code somewhere, a method that would get called, and we would pass either the whole user class, which would contain the login and password, or we could just read the login and password values out and pass those on to the method so that we could log the user in. Classes also support something called inheritance. Inheritance allows us to factor out commonalities in objects so that we don't have to keep repeating code. In this case, we've created something called a basic user class. We're kind of describing that every user is a basic user, and they'll all have some kind of a user ID that probably ties to something in a database. All users, when they're created, we store their created date, and we have another Boolean flag that tells us whether that's an active user in our system or not. So what we really want to do is we want to take another class that already has some properties. Maybe what we want to do is combine our user with a basic user so that we have the login and the password from our regular user, and maybe also we need the user ID, created date, and is active. In our case, we're not required to tie basic user to a login. Maybe a login's not even a user, and in our application, that concept doesn't tie together. These are things that one of your senior developers or architects would probably flush out in the beginning. So in our case, let's talk about a billing system where we have all different types of users. Maybe to log in, there's a login user, but when we talk to people in the accounting department, a user to them is not login and password at all. They care about other things. In this example, we're going to use a class called billing user. The billing user, to keep it simple, is just going to be first name, last name, and some balance. Maybe that's how much is owed on this billing user's account. Well, what if a billing user also needed that user ID and the created date and the isActive flag? What we would want to do is we would want to inherit, let me go back. We want to inherit these basic user properties, and we want to add that to our billing user properties. And then if we had another kind of user later on, it also might need the user ID, the created date, the isActive. So we could keep reusing this basic user and merging it, if you will, through inheritance with our other user classes. So how would that look? The colon here after the class name billing user denotes that it inherits from basic user. It can also mean implements, and we'll get to that when we talk about interfaces, but for now, it's going to mean inherits. So we read this as billing user inherits basic user. And a way to think about that that's easy is to say a billing user class is a basic user. Billing user is a basic user, meaning that if billing user has three properties, first name, last name, and balance, because it is a basic user, you automatically inherit these properties from the base class, basic user. So let's see it in action. All right, let's create a new project. And you've seen this all before, so I'm just going to speed through it. We'll name this noblecause.classes. Let's create a player class, maybe that's playing a game. So I'm going to right click the project, which is underneath the solution. I'm going to right click the project and I'm going to go to add, and I'm going to add class. You also can go to new item and you'll see class in there. If you don't see that, you might have something different selected here. You can always search and type class, and it will narrow everything down with the word class, or that has to do with classes. And I'm going to name my class here at the bottom, player. This is going to create a player CS file. And notice this player does not have the same methods like class program and static void main. Remember that this method in program CS is what gets automatically called to run our program. So we'll be doing things with our class here in main, but we're going to first write some code in player so that it actually does something. First thing we're going to do is we're going to make this public. We'll talk about what this means in the very next video. For now, we're just going to type public, and what that does is it exposes the class player to other files so that we'll be able to use it inside the program CS. So now that we have a public class player, I'm going to make a field called public string name. By making this public, we're exposing name to the outside world outside of these curly braces. So when we create a player object from this template, we'll be able to get to the player name. So let's stop there. And now that we've defined a player, let's go to program CS and create one. So I'm going to say var player, or we could always, let's call it player1, is equal to a new player. And that's how we created one, right? Player is our class or our template. By typing new and the parens at the end, player1 will hold an instance of that class. So player1 now is considered an object. Player, helps if I type player1. If I type player1 and hit dot using this dot notation, you can see my field of name. You can tell from the help here that it's a field, it's a string, and it's in the player.name class. So if I typed player.name, I could say that that player name is equal to Jeff. Now, I can't just say player1 dot score is equal to, let's say, 100, because there is no, let's make that a capital, there is no score field or property inside. So I'm going to go and add that. So we're going to go back to player, and I'm going to make it public int score. And now if we go back to program, now that it has a score, you can see it's not underlined anymore. And we can console.writeLine, and we'll use our interpolation. Player1.name, and we'll put a dash, and we'll say score. And then we'll type player1.score. So what does that do? That prints out a string. That's just strings, right? And then inside our interpolation, we're saying player1.name and player1.score. So print those out. Well, let's run that, and we should get player Jeff dash score 100. So here we are, player Jeff score 100. Beautiful. One thing that you might notice is we are able to assign things to these variables, and we're able to read things from the object's variables as well. And C# knows how to do that based on whether there's an equals sign here and whether you're assigning something to it or you're just using it. Notice nothing is equal to name here, so it knows it has to read it, where when you're assigning with an equals, it knows it has to write it and assign it to the variable. So that's a cool little example of how you can make an object and pack in a couple of fields, and you don't have to make separate variables. Everything's kept together inside the player object. All right, now let's talk about some inheritance. I am going to right-click my project and add class. I'll use this method this time of using it in this little quick menu. And I'm going to add another class and call this one gamer. I'm going to make it public. Again, we'll go into that later in the next video. This time I'm going to put a field in there, public string gamer tag. The idea here is that everybody that plays this game has a gamer tag. And maybe we have different types of players, but every type of player is going to inherit, with our colon, the gamer. So now, even though we don't see gamer tag here, we're saying that player is a gamer. So if we go back to program now, we should have access to this gamer.gamertag inside player. So without changing anything else, player1.gamertag is equal to Savage Coder. So because player is a gamer, it automatically inherits and gets all of the things that gamer has. We can also put methods inside of our objects. I can put something like public void update score. And I can tell it to take whatever is in score and add to it the new score. So anytime we call update score, we'll pass in a score value that this variable or parameter will take on, and it'll add it to the score. So we should be able to call that. So now we're gonna come down after we print out the player and the score. And if we want, we can add gamer tag player1.gamertag. And so I'm just going to copy this guy. And before I write it out again, I'm going to call player1.updateScore, and I'm going to pass it 150. So since I pass in 150 to update score, it will call player.updateScore. This will come in this time at 150, and it will add 150 to the existing score, because that's what plus equals does. Let's try that out. So gamer tag Savage Coder, player Jeff, score 100. Then we called update score, and we printed out the same thing again, and this time it's 250. So you can imagine as things happen in the game, we're calling update score and we keep updating the score. The other thing we could do is we could move some of these. Let's say we had another kind of player. We want to add another class called super player. And we'll make this one public so that we can create them. So super player is going to have a pet. So we'll say pet. And we'll say player pet is the field name. Now, we haven't defined what a pet is yet, so we have to make a class for that. So we'll add a class called pet and make it public. And a pet will have a name, and a pet will have a pet type. So maybe it's a dog or a cat or a Pokemon or whatever it is. So our super player has a pet. We also want our super player to have its gamer tag. So we're going to inherit from gamer. And now it has a gamer tag and it has a player pet. But doesn't it make sense now that our super player should also have all the things that player has? Right? Like a super player would still have a name and still have a score. So I think what we should do is we should take these three things, the two properties and the method, and we're going to move those up into gamer. So now everything that inherits from gamer will have a tag, a name, a score, and be able to call update score all by itself. So not changing anything, our code here should still work. And it does. And then if we want to go and create a super player, we'll just call the super player player2. Then we can set player2 dot gamer tag equal platinum 0. Sounds like a cool gamer tag. And then player2 dot name equals rich kid playing game, because he's got the platinum thing, right? And then player2 dot score, we'll just start him off with 1,000 because he spends all of his time and money playing this game. And player2 dot update score, we'll give him 500. Let's copy this down here and just make the changes so that it prints player2's information down here. And the other thing we can do here is we can, if we want to set up the pet, we can't really just do player pet dot name, and we'll call the pet Dodo. And player2 dot player pet dot pet type, dot pet type is equal to a Doge, right? This looks like it would work. but it's actually going to blow up. So when we run it, you can see that the debugger gets stuck on playerPet.name. Actually, when it tried to set the name, it got a system null reference exception with this error that says object reference not set to an instance of an object. What that means is there is no instance of an object for our class. Player 2 has an instance because we made a new super player, but we didn't ever make a new player pet. Remember, it's a class too. If you look back at the definition of super player, player pet is of type pet, and pet is a class of its own. So we can't just assign the name. There's two ways to solve this problem. We can either here put player2.playerPet equal new pet, and that would work. No more errors. Now that player pet is initialized as a new object, you can see that we started to, let's add to this dash pet and player2.pet. Player pet is the name of the property. So if we run that, you can see that the pet, whoa, what happened? What happened is we told it to print out player2.playerPet. PlayerPet is an object. C# doesn't know what you want to print out to your console.writeline because PlayerPet can have multiple things in it, right? Like our player has a gamer tag, a name, a score, a pet has a name and a pet type. Well, what should PlayerPet print out? It's not going to make any assumptions. So what it chose to do is print out the type of the class, which is a noblecause.classes.pet. Noblecause.classes is the name of our project, and pet is the data type of our player pet. So it just put what it is. If we wanted to type the name and the pet type, then we have to specifically name those so that C# knows what we want to print out. So now it says pet dodo is a doge. And maybe we could even improve on that a little bit by saying is a doge. And the other thing to note here is notice that we were able to call player2 update score, even though super player, which is what our player2 is, super player doesn't have an update score. But because it is a gamer and gamer has update score now, we're able to call that. So that's the basic concept of a class. We're going to go through scopes next, and then we're going to go through namespaces, and we're going to use all this stuff after that in an actual application that we're going to build. And I think you're really going to enjoy seeing all these concepts in action in a real application. So till then, make sure you practice as always, and practice your classes, nest classes with other classes, try some things with inheritance, and try to model some real world things with classes so that when you get to application building, which is coming up very shortly, you'll be comfortable with using it. All right, that's it for today. I will see you online.